All right. All right. Oops, that's my YouTube. Not that. Let's see if I here. All right, everybody. Welcome back to Day 4 of discussions C or classification. And today we're gonna also have do some math a little bit and have some familiarity with the main logistic regression. Haha, if you understand that reference, but not really. But yeah, doesn't matter. Yeah, we're gonna talk a little bit about how logistic regression works and what's the difference between logistic regression and linear regression. But again, you don't really need to like fully understand everything about the math behind how this algorithm work. You can just kind of see that, okay, this is what kind of makes sense to me and on why the math tells you that this will work. And then you generally just apply the algorithm to your own data. You don't have to like fully understand everything. So if you understand it, don't understand everything, just don't worry about it. It just work. Okay. And today we're gonna go with the logistic regression, and then after that we might go into the break out into groups, two groups, and then have you guys start to brainstorm about ideas or anything. But that's gonna be probably be the second part. But let's for the first part, let's get into the logistic regression first. Then, all right. So logistic regression, what is it? But before that, let's make sure that you understand these two terms. So what we learned so far about the linear regression. So linear is a line, right? Linear is basically finding the trend line, and you predict a continuous quantity output by finding the trend line. So it's going to be this when you have the data, all the data sets, right? And you try to draw the regression line, right? The best fit line to capture every data. But that's one thing. That's regression. We also have another thing, which is the classification. So basically, you're trying to classify data into either class 1 or class 0. So basically, there are like two. So this is like the simplest example of having two classes, and you're trying to predict if that's class 0 or class 1. So like, for example, if you have the data that looks like this, right? If the data looks like this, so this is like the first cluster of data. So cluster is just a group of data. And this is another cluster of data. So the blue one is a, say, class 0, right? And you have green one, which is, the red one, which is the class 1. And say you have another data that comes into here, right at this point, right? You might have to find a way to trying to predict whether the green one, does it belong to the blue, or does it belong to the red one? And from the look at it, yes, it's probably gonna belong to the red one, which is class 1, if I said it correctly earlier. But yeah, it's gonna belong into here. But in reality, it's gonna have the data doesn't look nicely like this. It's gonna have all kinds of outliers. Like they're probably gonna be like a blue one in here too as well, or it's gonna be like 3-dimensional, 4-dimensional, 10-dimensional, which you can't really just look at it and trying to figure out how can you classify the new data and see which class that belong to. So that's going to be the main concept of the classification, and probably the things that all kinds of uh, so-called algorithm or machines that you're going to be learning, and see like how what's the math, the basic math behind it, and how it works. So let's jump into the logistic regression, but it should be regius, but yeah, doesn't matter. Yeah. Anyway, haha. So we have linear regression, right? So suppose the data looks like this, and you basically says, okay, yeah, we're gonna keep, then we just gonna draw the data that looks like this, right? But internally, we just want to have the data that's gonna be at somewhere that says y is equal to 1. But if you keep drawing the line, right, the line is going to look something like goes all the way up, right? But if you suppose that you have another line that goes like, you're going to say like, so is it 1 or is it something else, or is it like 2 or 3, or I don't know about that. So we have some kind of like ambiguous problem with the, if you using the linear regression for classification. So we got to find a way to make the model doesn't go through the line of through the point of y is equal to 1 and y is equal to 0 as well. So that's when we use a different model, which looks something like this. It's gonna keep going from 0 all the way 0 here and 1 like this. So it's gonna look like some kind of S shape, and instead of like going all the way up to like forever, so like million or infinity, it just limits the output to be between 0 and 1. So that's going to become the logistic regression, which we will have a gentle introduction, hopefully, that you will be able to figure out, okay, so what's the difference between linear regression and logistic regression, and why it works. But even though you won't understand it, so it's okay, it's okay. I'll rest assured it's okay, because the furthest thing that you use is you just use the algorithm to work with your own data. You don't need to understand everything behind the concept of the model. But I'm just gonna also like have some explanation to help you kind of understand it a little bit and feels like that model makes sense to you. All right, so let's also look into further examples. So say if you want to classify data, right, you also have this first one. You have say you have a mail, right, and you want to classify whether your mail is a spam or not non-spam. So you want to look into every words of the mail and see if there's any like kind of flag word that you might spot it, and then just classify it as a spam. Or if you want to see if based on the weight, can you classify the weight that whether a person is obese or not obese? And you can also classify into different class as well. So for example, you give it a data. Is it a bird? Is that a bird? Is that a plane? Is that Spider-Man? Nah. Is that a bird, a dog, or a cat, or something like that, right? So that's also another type of logistic regression that you can also predict with multiple class. And this is also another one, like say if you have a patient and you want to see if how many cigarettes do they smoke, and based on the number of cigarettes that they smoke, will they are they going to have cancer, or are they going to have cancer or not, right? So let's see how, okay, so the key idea is that this given an input, which class does this input belong to? But if I have to elaborate a little bit more, is that the logistic regression, when you're giving an input, what is the probability of this input belongs to class A? So in case that you don't know, probability range from 0 to 1, right? So like say if you flip a coin, the probability of landing a head is 0.5, right? And a tail is also 0.5. But if there's something that's going to be always happen, the probability because it's going to be 1, right? So it's say if the sun will always rise up, and this is always said, right? So that's going to be probability is going to be 1. But something that never happens, so like say, can't think of anything, like probably of I can do backflip, that's 0 or maybe 0.1. Yeah, that's also like say like there's a low chance of that to happen, while 1 is like it always happen. So that's also like the little concept of probability. which gonna be helps us understand more about the concept behind the logistic regression after this. And let me see. So yeah, so let's see some example. So suppose that we are given with the so ignore the graph first. So suppose that you are given the data that looks like this. We only have the data that says the tumor size. So the tumor size goes from here, right? Go like that. And it has the data that lies on the line, and then it's ranged all over the place. So you want to kind of project the data onto this blue line. So once you project it up, so it's going to look something like this. But how do you project it? So that's going to be like the later part. But let's assume that you just know that you can project the data onto this blue line, right? So once you project the data on blue line, it's going to look something like this. That the data relies on this logistic regression line, and you're gonna say that you're gonna make some assumption. So I say, how do you gonna define the tumor size? That if the tumor size is if the no, we should look at the y-axis then. So the y-axis will range from 0 to 1, right? So then you're gonna find out, okay, if you have the number between 0 and 1, can you kind of like split between that to make it two graphs instead, right? So then between 0 and 1, let's pick 0.5. That's gonna be the middle line between 0 and 1. So let's pick that. So in the y-axis, we pick 0.5, right? So it's gonna be something like here. And with this, you simply just said, okay, so if this line, this point, if the y value of that is below 0.5, let's just classify them as class 0. So let me just write down. So if y is less than 0.5, we just go into class, assign it to class 0. Or if you want to go more specific with this example, it's going to ask if the tumor is it malignant or is it benign. So if it is less than 0, then we suppose that we just assume it to be benign. We should just say like the tumor is not dangerous. It's not dangerous for your body. Otherwise, so it's going to be y is greater than 0.5. So it's going to be this section. You're going to say that tumor size looks so big. So you're going to say, okay, then if the tumor size is quite big and it's above 0.5 for your y value, then you're going to say it's going to be classified into class 1, and it's going to be malignant tumor, or it's going to be dangerous for your body. It can potentially cause cancer, right? So that's like the whole concept of how can you use based on the data, based on the given input, which is your tumor size. How can you classify the data? You just project it to this blue line, and then try to draw a line that can classify the data between class 0 or class 1. Or it should be class 0 and class 1. So far so good? Thumbs up? Kinda, eh. All right. Still a little bit confused. All right. All right. Nice. You guys are catching that quickly. So yeah, but if you're still stuck, then also feel free to ask me anything, okay? But just some side note. See how we like say we set the 0.5 to be like the splitting line, or we can also set the 0.5, or we call it threshold. Let's write that down. We can optimize the threshold to be something else, something other, whoops, then 0.5. Because it's not, sometimes it's not gonna always be like that. Sometimes you might believe that, okay, just set it to 0.2, that's also good enough, because you want to, like, if your tumor is around, this is 6, this is 8, it's like 7. Sorry, at like scale of 7 already, you just classify them as a malignant tumor so that you can save patient as soon as possible, or something like that too. You can also like try to set lower the threshold down from 0.5 to somewhere else. But that's also, like, again, part of that's also part of your data analysis on how can you, if you want to lower the threshold. But if you don't trust your analysis, there are also other way to, like, kind of like measure how will this threshold perform as well. But I think it's gonna be tomorrow, hopefully, if I don't go too far ahead of the lecture. But yeah, that's something for you to look up. And
oh wait, threshold is usually just going to be the average, right? Or it's going to be like that middle value always.
Yeah, people, it's gonna, let's say, not typically not average as far as I'm concerned, because it's gonna be range from 0 to 1. It's always gonna range. The wide range is gonna be 0 to 1. So that if you're talking about average, then I assume that, or it can, so then can the y-axis go from 0 to like 2, and then the average is gonna be 1? Then no, it's gonna be always set from 0 to 1, and then it's gonna be your hyperparameter, which is something that you have to pick out by yourself. And it just 0.5 is for our convenience, since that's like the middle point, but it doesn't always work every time. So yeah.
So just in this case, it would be 0.5. However, another case, we can set it at like 0.7 or something, like
Correct.
depending on what would actually be considered malignant or benign.
Yes.
Okay, I see that. Okay, thank you.
Yes, fellow Gura, you got it. You got it so quick. Nice. All right. So okay, let's go back to something that I also mentioned at the beginning of this problem. So we say like, okay, let's assume that we have this line for us already, right? But then what does this line really is? What is the line really be? So it's gonna be this. This one, you see, yeah, this one is just ask for us to ask, like, if how can you make this curve, this line, this curve, so that we can project the data onto here. So that's gonna be the something called logistic function, which is where the name comes from the logistic regression. You use the logistic function to project the data onto the line, and then set threshold to classify the data. All right. So let me see if I can try to further write it down. But yeah, this is just the equation of it. You don't have to memorize it. You just know that if you project the data onto this line, it's gonna produce you this line of data, and you can like plot the data in here and then try to classify it. And let's see. So yeah, let's go with this too. It's gonna be, so I'm gonna also draw the right line to kind of like further explain what's the logic behind it. So suppose the horizontal one is the z-axis. So let's forget about the notation of xy for now. Let's suppose this case we use the z as our axis, right? So this one goes also z, which is just a number, but yeah. So if you look at the line, right, and then we say we also use the same one, which is threshold, as our 0.5, right? So this is our threshold, so it goes like this. So then we can see some kind of relationship that suppose that if the z is less than 0, then it's gonna be it's always gonna be classified as class 0 in this case, right? So then I'm gonna highlight and color everything here, and it's gonna be class 0, and up here it's gonna be class 1. Maybe this is a little bit misleading. Oh no, probably not, because I'm talking about if you have a data like you project up to the line, it's gonna give you this, which gonna be below the point, so that we classify it as a 0. Otherwise, it's like line, the points lies on them. Z equal to 2. We just project it to a line, and then we simply classify it as a class 1. So let me also write that down. It's gonna be if Z is greater than or 0, which gonna in turn give us the phi, or which is the y-axis on this one. Phi of Z is gonna be greater than or equal 0.5, and then it's gonna belong to class 1. Else Z is less than 0, then we're gonna have the y value, which is this one, phi of Z. It's gonna be less than, no, it should be less than 0.5. Then that belongs to class 0, right? And if you also like try to see from this graph of z-axis, is we can see that if the z becomes less than 0, it's gonna be so like this, -1, -2. It's gonna be let me color that here, right? Everything behind that is gonna be class 0, and same thing as the other side. Everything here is gonna be class 1. All right, a little bit more that I want to also explain one. So I said before that, let me take that. So I said before that let's ignore Z for now, but now let's come back to it. So what exactly is Z in this case? So Z is actually, yeah, the notation is kind of like keep jumping all around, but Z is also the equation of our model. So which is just this, same thing as we like go over again and again. So it's gonna be f of x, but we also just represent to Z in this case so that I can fit that into the line, the line equation. But generally it serves the same thing, right? So it's gonna be same thing of beta 0 plus beta 1 x1 plus beta 2 x2 2 plus dot 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 until some of the end of some feature, right? But in this case, let's just make it as a general line equation so that it doesn't really confuse us. So let's just remove everything else for now. So basically, this, remember, this is going to be our data, and then when we have our data and some kind of model, we will get the sum value, which is the z, and we put the z value into this graph, and then you try to classify based on that value that you input the z inside the phi function, which is our logistic function. What's going to be output, which is supposedly going to be between 0 and 1. And if it's both 0.5, then yeah.
I'm sorry. I saw that you have beta 0 and beta 1, but isn't that like a linear equation, and we're trying not to use a linear equation?
Yeah. So that's also kind of yeah. So I guess in a simple sense is that yes, you have the linear, you have a linear regression. Yes, this is based as, yeah, I think as Ethan also said, that kind of looks like linear regression. But then we want to find a way to transform that linear regression into classification, because remember we have, yes, we have this, which is f of x is equal to beta 0 plus beta 1 x, right? But in order to classify, we want to draw, as we said, in order to classify, we want to set threshold and see if that's below the threshold or not. So we want to, and we want to somehow limit the y value to be between 0 and 1. So then we're going to transform the linear regression into some and plot that onto the logistic equation so that we can classify the data. So yeah, that's kind of like expand in a way. It kind, the logistic regression kind of expand the concept of linear regression so that it can serve the purpose in the better sense than using the linear regression to do the classification. Does that make sense?
Yeah, so you're like transforming it instead of just creating a new equation.
Yes. Because there's also some in like other way, like if I can, let's see if I can think of some example that linear regression doesn't work when you classify data. Can't think of it, just Google, I guess. When linear regression does not work. Yeah, something. Not that. Not that. Maybe I can get it to you guys maybe next class instead, I guess. Sorry about that, because I don't have like a concrete example that I can think of at the moment. Yeah. Maybe I'll get back to you.
Wait, wouldn't linear regression usually not work if it just underfits the data? So like if you find like a database that has like maybe is more broad, for instance, or has more curves, then maybe you would want a different type of set. So that's why you'd usually end up changing to a logistic regression instead of linear. That's what I was thinking.
Yeah, but I don't think they like how spread of data and underfit really like serve as a main motivation to change the data, because generally the main motivation that we change from linear regression to logistic regression is that we want to classify the trend line. I mean, not classify, sorry, try to get the trend line. But classification, we want to kind of group them together and then kind of like draw the line that like classify the data like here, instead of like going through it like that. Instead of going like this one, we want to draw like the line that separate the data.
Okay,
so that's like our main motivation of we are not using linear regression. Yeah, but I don't know if that's like a good concrete example that can visualize it. Yeah, I guess maybe you can think of it for now that, yeah, linear regression, you want to capture the data, but for classification, we want to somehow draw the line that separate it rather than just draw it onto the line. Yeah. Okay, maybe we can go with that for now, and maybe if I have like a better explanation, maybe I can come up, let you guys know like in tomorrow. Yeah.
Okay, I see. Yeah.
Yep. All right. Nice. You have lots of interaction. All right. So yeah, I also touched that a little bit. Yeah. The goal of classification is that we want to draw deoxidation boundary. Haha. Nah, it's decision boundary. So suppose that, yeah, we have the data look something like this, right? We want to draw decision boundary, and that decision boundary is also again, it's also a line equation, which is just f of x equal to beta 0 plus beta 1 x. And that line is going to be draw that so that it can separate the data. So one side is going to be class 0, and the other one is going to be class 1. So yeah, something like that. Right. But that's gonna, but this one, in this example, it has like all kind of outliers and then etc. But that's also, that's just for like later part, maybe also later part of the course. So just ignore it for now. So we just know that we're gonna create a line that separate data into two classes. And this one is an example of 3D. Like you can also draw, instead of a line, it becomes a plane when you're working with 3D, and then when you're working with 3D, you draw a plane to separate data like this. And let's see. And yeah, when it comes to the threshold, as we've also discussed, like why do you put it to like 0.5? Can you, and is there a way that you can like so-called measure how well that threshold performs? So it's gonna be we're gonna use a method called likelihood. So this is how it works for likelihood. You can even see some like weird notation for the likelihood, but I'll just write down in plain English. And again, you don't have to like fully understand. And I'll go into like some example to see like why does the equation kind of make sense, but you don't have to like memorize it. You just kind of look at it and see why it makes sense. So it's going to be product of phi, and it's going to be z and one particular point of z. So you can just put it in zi of points. And we spell that points in class 1 times the product of 1 minus z. So again, z is going to be the output of the logistic function, right, of points in class 0. Right. So let's see in the example and see how that this equation works. But then let's see. Oh, yeah, I guess like before that, let's do some like some simple math equation, or some simple math algebra, right? So if I ask you 0.9 times 0.9, is it greater than 0.9 times 0.1? The answer is obviously yes, right? So then suppose that you go with 0.9 times 0.9 times 0.9, and then keep on forever. Not forever, for probably like go like 0.9 10 times multiplied by itself for 10 times versus 0.9 times 0.1, and then goes and then times 0.1 times 0.1 together. We're gonna see that the 0.9, the 0.9 power to the power of 10 is gonna have a little bit higher value than the 0.9 times 0.1, and so on, right? So then that's gonna be the number that you're gonna try to measure that how well it perform. So that's gonna be our likelihood. So let's see example. So I think that's like, that would make more sense to you guys. Let me change color. So let's see. So we just use L to show the likelihood, but I think it's generally like they use like some kind of fancy L, something like this. But yeah. But I guess context matter. But yeah, let's just see how it goes for this. So let's follow the equation, and this is our example, right? So I assign the blue one becomes as a class 1, while the red one becomes class 0. So let's calculate this. So again, if we kind of set the threshold at 0.5, right? 0.5. So let's assign that. So let's see. But the blue line, I mean, let's look at some case. So if you assign everything below 0.5 to be class 0, right? But this is the true value. True value, it says that true value, it should be classified as 0.1. So like say if this blue one, excuse me, blue one supposed to be the class 1, but it got assigned kind of incorrectly. So that's something for you to look out to. But let's clarify if 0, but then you said, wait, that's the blue, so it should be class 1, right? But if you draw the line, then you're gonna predict it that it as a class 0. Yeah, that's also some thing for you to look at. But let's work on the equation. So we have equation that looks like this, like so likelihood is gonna be product of the phi of z. What are some in the class 1? So it's gonna be this blue. Wait, let me think if I can like classify more. I think this one should also clarify right, like observe value instead of like prediction. Sorry, I took it back. I want to take that back a little bit. It should be observe value. Let me also double check with this real quick.
Wait, what's the phi value that you're showing, by the way? Like when you say product of 5 zi?
Oh yeah. Yeah, again, phi is the output of the logistic function. This one.
Oh,
so it's gonna
okay,
be
I see
this
that. Yeah.
axis.
So just you're saying like that line basically is, then you're saying like the zi. Okay, I see that. Okay.
Yeah. So when you input the z, and then it will magically output you the value between 0 and 1. So that's gonna be our logistic function. Yeah.
Okay, I see. Okay, thank you.
Yep. Yeah. If you're lost in the notation or anything else, feel free to ask me. And we're gonna draw something like this. So we have. Let me get this on it. So product of phi of points in class 1 from the observed value. So it's going to be these 4, right? These 4, and this. So it's going to be 0.9 times 0.9. I think 4 of them, 0.9, or maybe like we can go with 0.8 times 0. I think this one could go with 0.4. So that's going to be the first. So this is going to be this first part, and then the second part is just 1 minus phi of that. So it's going to be times the product of everything. So it's going to be 1 minus, so 1 minus, we can go with this. So start from the bottom first. The bottom, it doesn't matter, but let's go with the bottom so then I can also explain it. So the bottom one is I would say 0.1, right? So the bottom we have 1 minus 0.1. So that's going to be the phi value times also another point, which is 0.1 times 1 minus, so this one say supposedly 0.3 times, and then the last one is 1 minus, let's see, 1 minus 0.9, I would say 0.9, right? So that's our, and then that's it, and then that's our equation. It's going to be, let me see if I can also grab that. Well, maybe I'll skip the calculation and let me do the calculation real quick. I'm going to give you 0.9 times 0.9 times 0.9 times 0.8 times 0.4.
Wait, should we write this equation down, by the way, for later, or should we just keep?
right.
Math again.
Yeah.
Should we write this equation down for later as well? By the way. You think okay, yeah.
What do you mean? Because are you talking about like should you write down by yourself, or should I also like should I just
no? Should I or should we as?
No, I don't think so. I don't think because again, I don't think you have to memorize it. I think you have to know like how can you measure the performance of it.
Mm-hmm. Okay. Okay.
So, yeah.
Okay. Thank you.
So you don't worry about it. Yeah, just know that there's an equation that people come up with, so that you can just do it by yourself, or you can kind of like apply it to it. So yeah, I just want to show you this is one way that people get the equation, and you can just use it by yourself. So let's see. So yeah, so this is going to be our equation. No, it's going to be our likelihood. So this is going to be our likelihood value. So you can actually say this whole thing is the concept of how we can measure one threshold works better for likelihood, right? But and our goal is that we want to maximize the likelihood. So like going into like the first time they also discuss like if you have 0.9 times 0.9 times 0.9, but suddenly you have, but if you go if you suddenly change the threshold, it's going to become something like 0.1 times 0.1 instead. So then the value we're going to have some kind of difference between it. So then when we multiply when we multiply the phi value together, we want to make sure that the phi value is like the highest value instead of you keep getting like 0.1, 0.1, 0.1, and then that would not work, right? So like say if you have, let's see, let me if I can get like, wait, let me make sure that I do this everything correctly. Sorry, give me 1 minute. I want to like double check with that if I make it correct. Shoot, yeah, I think I got the idea incorrectly. I think it should be which. Let me just okay for keep everything, keep the concept of like finding a livelihood, but change. I want to change something with the goal of it. So the goal of it, we want to know which threshold. It shouldn't even be threshold, which kind of how it should be which curve, slope, or steepness. Is that word steepness? If I recall, but yeah, we want to get the slope. We want to kind of modify the curve so that it will kind of classify their points correctly. So for example, if let me just redraw it again. Yeah, sorry about that. I got the concept slightly wrong, but I can explain it again. So this is what we want, and say if you have this, and here, and we have this here, right? And then we have our line is supposed to look like this. That's our logistic function. So then when we draw it, this is just a same representation. When you project onto the data, it looks like this is here, and here, and here. And then we're gonna say that, okay, so then the left side is gonna be class 0, sorry, but then the right side is gonna be class 1. But can you imagine if you say, okay, I don't like that line. I want to make it to look like this instead. So then when you projected the line of it, you're going to have this one. Sorry, this is so messy. You're going to have this left side, which we're going to assign as class 0. But then the right side we assign as class 1. But you see this line, this point, this data point, as a class 0 instead of using the old one, which we have as, let me see if I can get other color. Let's go with the black. Okay, sorry. Instead of this, right? So you see that if you correctly assign this line, this point to maybe at the bottom of this line, you're gonna get. And again, if you look back to the equation says if it is in the class 0, get the product of 1 minus phi of that point. So then if you keep this, if you keep using the purple line instead, you're gonna get 1 minus. So if you draw it up, it's gonna give you like 0.1, which give you 0.9, right? But if you don't modify the graph, you're gonna project the line up to here. But then up to here, you're gonna give you like 0.9 instead. And again, the likelihood function shows you that it can be 1 minus phi at that point. So it's gonna give you 1 minus 0.9, which is 0.1. And 0.9 is greater than 0.1. But the goal is that we want to we want to keep the maximum number. So again, let me reiterate that. So the problem for this for the logistic equation is that we don't know what's the line going to look like. So we use, in order to correctly classify the data, so we use likelihood, and the likelihood is just keep finding the product of it of the points. And if the product of a point is correctly classified, it's going to get you some high value. But if it's not, so like this one, which is projecting to up here, if it's not, then it can give you some low value. But our goal is that we want to maximize every value so that it will classify it correctly. Yeah.
So does the computer like go through each point and see which one gives a bigger value, like a bigger product? So like goes through the first point and let's say it's like 0.1 and it sees that 1 minus 0.1 is greater than just 0.1. Would it like do that and then continue on, I guess, like trying each point?
Yeah, that's a good question. So I would like to step back a little bit. So remember about the cost function of linear regression. Yes, we can also use the same concept of like finding the gradient, finding the derivatives to get the minimum value of the cost value. And again, we are also trying to find the derivative of the likelihood so that we get the maximum value of the likelihood.
Oh.
So we basically also use derivative to find the maximum. So yeah.
So it's like the opposite of finding
that. You don't have to.
So it's almost like the opposite of finding the lowest point.
Mm-hmm. Yes. So yeah, so you're gonna get some kind of likelihood function, and then you'll find that the likelihood function is gonna look like some kind of the bell curve, or I'm not sure if that's the visualization of it. I don't think I put that down here. Yeah, sorry, I didn't put that down. Let me also look up to likelihood graph machine learning. I believe it's like it's gonna look something like this. Oh, why is there? This one doesn't look like here. I don't know if that's the great one, but oh yeah, we can do this. Basically, if you have this is also a good picture. So then imagine the top one, which is our model. It's gonna tell you how well the model capture the data and then kind of classify it correctly. If you if you can like capture every data and then classify them correctly, you're gonna get this the bottom half, which is gonna be your likelihood, and then you find the maximum, which is just the maximum value, which is just finding the derivative and then set it to 0, and then it's gonna give you the point that gives you the max, which is 2 in this case. So yes, that's the I think that's a long answer for that. That how do you know that you put the graph correctly, so then you get the maximum likelihood? Kind of okay. And again, you don't have to like worry that much. You just know that when you use this, use the likelihood, and then you find the maximum likelihood of it, it's going to give you the best model to do the classification. So yeah, this is just a layer. Yeah, Ethan, are you going to say anything?
Oh yeah, I think that makes more sense. I was more thinking that the computer like just tried every option and then tested, but this makes a lot more sense just to find a derivative.
Yeah, I don't know. I'm not like 100% sure if that also works. I think that also works, but might be like too many steps and too like computational expensive, because there's going to be millions of data, and I don't know if that's like a good way to like keep doing everything. But yeah, but at the same time, I'm also not sure like what's their logic, all of the computational logics behind the finding the maximum likelihood of that too. Like, I've accidentally locked that. Give me 1 sec. Screen share it, dang it. Let's see. Give me 1 moment. But yeah, any other questions? Hold up, let me close my program and then reshare it. Give me 1 sec. But yeah, can I get like maybe 10 more minutes, all right, and then we'll take a break, and then we'll come back to the like all the Go project and stuff. But yeah, let's go for the final push. Right? So as I said, we have the z value, and then we assign it to the logistic function. But technically, z is gonna be your beta 1x plus beta 0, right? So then this also leads back to the previous slides of like, hey, can you like modify the graph? Can you modify the logistic graph like this one, so that it will capture the data well, right? And it's gonna be this one. So it's gonna be with the visualization. But let me grab my PowerPoint too. And yes, I stole this slide from Stephanie's. So yeah, thanks Stephanie's. Well, yeah, she's in a discussion.
Oh wait, Ken, are you sharing right now, by the way?
Oops, yeah, I forgot to share it. Dang it. Again, I hate technology, but I like it because it's convenient. But you know, I digress. But yeah, thanks for catching that. Let's come back. So yeah, we went over the likelihood and why you want to maximize. You can maximize the likelihood in order to capture the data and then kind of classify it correctly, and then hopefully you project the data to the correct correct phi value. But remember that we assign the z value into the logistic function, right? But actually the z is just a line. Well, for now, let's keep it 2D. For now, for the 2D, we have the z is equal to beta 1 times x plus beta 0, right? And then you see that if you modify the b1 and b0, that's going to modify the curve of the graph as well as the where the graph is facing. So you can also face backward as well, and then or you can make the stiff like go really slowly like that too. Which in turns, if you modify the beta 1 and beta 0, you're gonna be able to capture the data better, and then you will get the maximum likelihood. And that's gonna be something that looks like this. Let me switch to my PowerPoint real quick. There. You're gonna see like you have, so you're, you see my mouse? I wonder if you see my mouse. But yeah, so if you look into like the equation, you're gonna see like one over blah blah blah. So it's gonna be e to the negative z, but then z is actually beta 0 plus beta 1. But if you change the b0, it's gonna switch. It's gonna kind of change where the z, where the interception point will be. While if you change the b1, it's gonna change the how the slope will looks like for the graph. It's kind of like that. Yeah, and then that's gonna come into the point of how can you, like, if you modify the likelihood and goes back and forth, you'll be able to get the correct b0 and b1, and then you will capture the data very well, right? And yeah, just a side note, generally people use log likelihood, and people use log likelihood simply because you can take the derivative of log likelihood in an easier way than if you keep using the log or keep using the likelihood together. But yeah, just in a simple English, you just need to know that it's easier to do complex math when you're working with the log. So that's something for you to be aware of too. And yeah, to simply put, likelihood is equivalent to the logistic regression cost function. So you want to maximize the likelihood, while for the logistic regression, you want to minimize the cost function. And yeah, that's pretty much for the logistic regression. So basically, to summarize everything that we learned logistic. The logistic regression is a way to categorize, classify data into a class, and we want to maximize the likelihood to get the best logistic regression model. Yeah, so let's take 10 minutes break so we can come back to 2:16. Yeah, take a break, and let's see if we want to come back and we can discuss, like, if you want to go over with the homework or you want to, and we can also start brainstorming on the project as well. All right, guys, it's 2:16. So let's see. So we can also have. I'm gonna have you guys discuss the project, and we'll also potentially, not potentially. Yeah, I'm gonna have to break up you guys into two groups, and you guys also have to like maybe start sharing your information, or maybe put you guys in together with your own Discord. And I recommend that you guys should use Discord so to communicate with each other. And yeah, definitely use Discord and try to brainstorm the idea first. You don't have to come up with like the ideal topic at the moment, because we still don't have not finalized the guideline of the project. Ideally, professor want you guys to propose some of the propose an idea to me, and I'll give it to her by tomorrow. But I'm not sure if that's gonna be changed since uh, the guideline has not come out yet. But other than that, yeah, just start talking about it and maybe give it to me by Friday. And if anything, I would say I'm kind of allowed for you to change later if you feel like you change later within like next week by like Wednesday. That's like the hard deadline. If you guys feel like you want to change it, but let's start it by having you guys discuss among yourself first. But and I think I can also stop recording, and then other than that, I don't think I have anything else. Yeah, and but I'm thinking about if after I have you guys do the sharing information and everything, I'm just gonna stay in this room, in this room probably until like no one leaves, or maybe I can also stay until 4 anyway, and then you guys can, if you guys done with like sharing information, we cannot I can also stay here, and if you guys have questions with the homework, I'm also happy to help, and I'm still stay in the main room too. Yeah, I think that's the logistic of today, and I'm gonna stop recording and start talking about group.